For nearly 30 years, cosmologists agreed on exactly how the universe dies. It keeps expanding, cooling down, until the last stars burn out, leaving a cold, dark void. They call it the Big Freeze. But a recent study, released in November 2025, shows astronomers might have misread the cosmic signs entirely. To grasp the magnitude of this discovery, we have to map out the territory. The observable universe stretches about 93 billion light-years across and contains roughly 2 trillion galaxies. Across every inch of that vast volume, 2 opposing physical forces are locked in a literal tug-of-war. Whichever side pulls harder determines how reality ends. On one side is gravity. This is the inward pull, acting like a cosmic brake trying to collapse the expanding universe back together. The bulk of this gravitational pull comes from dark matter. We cannot see it, but it accounts for over a quarter of the cosmos, forming an invisible web that binds massive galactic clusters to one another. Pulling in the exact opposite direction is dark energy. This is a mysterious outward pressure, actively stretching the fabric of space apart. In the late 1990s, scientists tallied the score between these two forces. They measured the expansion and determined dark energy was the undisputed victor, pushing galaxies apart at an ever-accelerating rate. An accelerating universe quickly became the absolute bedrock of modern cosmology. Everyone built their models on it. But that foundation rested on a single, fragile assumption. Astronomers calculate the expansion of the universe using dying stars called Type 1a supernovae. Because researchers believed these explosions all burned at the exact same brightness, they used them as cosmic standard candles to measure vast distances. When researchers analyzed distant supernovae in this imaging data, the light arriving at Earth was significantly dimmer than predicted. This meant the stars were further away than expected. The only mathematical explanation was that the universe's expansion was speeding up. The scientific establishment embraced this conclusion completely. It won the 2011 Nobel Prize in Physics, and cosmologists agreed that a constant, unyielding dark energy makes up 68% of the universe. However, the math only works if those standard candles are truly identical. If something else was making the stars look dim, the theory of cosmic acceleration would collapse. In late 2025, researchers from Yonsei University and the DESI project identified exactly that kind of flaw. They called it stellar age bias. Standard candles actually vary. Supernovae from older stars produce brighter explosions than younger ones. Since the distant universe contains mostly younger stars, those ancient explosions naturally looked fainter. By standardizing this flawed data, scientists artificially inflated the expansion rate. The researchers applied a correction for this bias and merged their data with measurements of ancient sound waves from the Big Bang. When they ran the new numbers, the acceleration vanished entirely. The data shows dark energy is not a constant force at all. It is weakening, and the universe has already started to slow down. If dark energy is losing strength, a cold, freezing death is no longer guaranteed. It means gravity and dark matter have a chance to mount a comeback. Over trillions of years, their collective inward pull could finally overpower the outward stretch of space. In this scenario, the expansion halts and reverses. The cosmos begins to shrink, drawing every galaxy, star, and black hole closer together, until they collapse inward on themselves in a final, infinitely dense event known as the Big Crunch. The universe's timeline is not a one-way trip, but a dynamic, shifting balance of power. Which raises a profound question. Why are the forces of expansion and contraction fighting such a tightly matched battle? The late physicist Stephen Hawking offered an elegant solution. He proposed that the positive energy of matter and the negative energy of gravity cancel each other out perfectly. This visualization illustrates his zero-energy universe hypothesis. Building a mountain of positive matter requires digging an equally deep hole of negative gravitational energy. Add the two together, and the entire cosmos sums up to exactly zero. We won't have to wait long to test these ideas. Facilities like the Vera C. Rubin Observatory will soon map tens of thousands of new supernovae, providing the definitive data needed to settle the dark energy debate. Nearly 14 billion years into its existence, the universe is still hiding its ultimate fate. forcing us to constantly rewrite the absolute rules of reality.